Hello, everyone. Good morning from the state of Maine. Welcome to the 8th in our GeoTalks Express series. I can't believe it's been 8 already. Wow. Today, as you see on the screen, we're going to be talking about drones. We're going to be talking about UAVs. The title of our presentation, Got a Drone, Now What? Leads us into this question about what can we do with drones? How can we derive from the data we capture from our drones? So we're going to, as part of this presentation, introduce you to a component of Global Mapper that lets you take drone collected images and go through a process to create a 3D environment. Those of you who joined us last week, sorry, not last week, the week before last, heard from the folks at LiDAR USA about some of the work that they're doing in various parts of the world using this functionality. So we decided to kind of give that a little perspective. We would introduce that tool in Global Mapper. So over the next hour, we're going to go through a simulated workflow where we're going to take some drone images and see what we can do with them. An introduction to the Pixels to Points tool. I'm joined today by my colleague, Mackenzie Mills. Good morning, Mackenzie. How are you?
I'm good. Good morning, David.
Good to have you with me. Good to have a sidekick. It's always good to have somebody. It's always good when technology works. I've spoken to colleagues in the past and there's been silence. It's always good when that connection is made. I know a lot of you have been in our sessions in the past few weeks, but for those who haven't, a few housekeeping issues to cover before we get going here. Activate my slide. So our webinar format. You are in listen-only mode. I notice a few attendees still coming in, a few latecomers still arriving, but you're all in listen-only mode, which means obviously you can hear Mackenzie, you can hear myself. Unfortunately, we can't hear you. If you want to ask us a question, you can ask verbally, but again, I won't hear you. So your better choice is to use the questions panel on the right side of your screen. You'll see that right over there in the GoToWebinar panel. You can move that panel out of the way if you want to. You can move that around on your screen, but it will dock by default over on the right side. Ask questions if you want to ask about what we're doing, about some of the functionality. We may not be able to answer all of your questions during the live session. We definitely will follow up. We have been accumulating the questions at the end of our sessions and answering those in direct email, also posting them on a blog. So whatever questions come in, we will try to answer those, as I said, in real time, but those we can't, we will answer later. The session is being recorded. I always have to check to see that is actually the case. It is recording. This will be scrubbed a little bit, edited a little bit, not too much, and then ultimately posted on our YouTube channel or to a specific playlist. As an attendee today, you will receive a link to that playlist, hopefully within the next couple of days, so you can go back and recap some of the content that we're going to be covering today. So look out for that email coming up again in the next day or so. A few sessions coming up after we get through today. We've got a number of others coming up next week, or the week after next, I should say, July 8th. It's a fun one. This kind of goes back to the basics of Global Mapper. I know for each session we have folks who are not familiar with the software. This is one you might want to take a look at. We take a lighthearted alphabetical trip through the application, going through ABC and pointing out specific functionality. I am going to make this a little bit interactive. I'm going to have the audience suggest some A, B's, and C's as we go through. And one of the things I often kind of throw out when we start this is what do you think is going to be the X? What functionality in Global Mapper starts with X? Any idea, Mackenzie, what we're going to do with X? I know you may not have seen this one before. Any idea what our X?
I haven't seen the ABCs, and I really don't know what X might
Well,
be.
there you go. There's a reason for Mackenzie to join us in 2 weeks, July 8th. Right after that, July 22nd, we're going to revisit Mango. We've had a brief presentation in the past about what Mango is. It's an online mapping service. We have a partnership with that company. You can publish your maps directly from Global Mapper onto a Mango map, and we'll cover that functionality in our session on July 22nd. August 5th, we focus on some of the content we're going to be talking about in the latter part of today's session, terrain analysis, but we'll go into a little more detail looking at some of those terrain analysis functions in Global Mapper. I know for a lot of you, that is one of the primary functions of the application, one of the primary reasons you are interested in Global Mapper, and we'll talk about that in detail. Registration information, if you note the URL at the bottom, is currently available for all of these sessions. Go ahead and go to GeoTalks. BlueMarble.com/GeoTalks SXP, and you can register today to reserve your slot. Today, what are we going to be doing? again, we know there's a lot of people coming to some. By the way, I'm just noting in the question, some people are suggesting my X's already. Thank you for the suggestions for what an X should be. We'll leave that one to next session. If you want to hold off on those questions until 2 weeks from today, we'll talk about what the X stands for. Back to today and our agenda. A quick introduction to Global Mapper. We know for all of these sessions, there are folks who have never used our software. I'm going to very quickly give you a high level, literally two-minute introduction to the application, specifically in the context of what we're going to be looking at today, which is drone data processing. We'll begin the practical session by loading the data we would have simulated in collecting on a drone. And we have some drone data. We'll go through the process of loading that. There's actually two different files or two different types of data we'll load. One is simple drone images. The other is ground control points. So before we begin the actual process of processing the data, we'll go through the process of loading them. I'm going to shift over to Mackenzie at this stage to talk a little bit about the technology, very briefly about the technology behind the process we're about to embark on, which is basically a photogrammetric analysis of our drone images. Structure from motion is what it's referred to. I'll leave it at that and let Mackenzie fill in the details of what exactly that entails. Then we'll come back into the application and actually put that into practice. We'll take a look at our pixels to points tool and again, go through the process of reconstructing our 3D environment using our drone images. And this is going to be time dependent at the end of our session today. Once we've created that data, we have a number of different workflows that we can go through to show how we can use that data. We'll see how many of those workflows we can actually get through. And again, if we don't have a lot of time at the end, you want to see more about how we work with that 3D data from a terrain analysis point of view, come back to that session a few weeks from now when you can get more detail on some of those tools. So that is the plan for today. Anything I'm missing, Mackenzie? I think that's pretty much covers what we're going to do in the next hour.
Yep, sounds good.
Got a lot
Looking forward to it.
Yeah, got a lot on our plate here. I'm glad I have a sidekick because there's a lot to cover. Let's begin, as I mentioned, with a quick overview of Global Mapper. I'm actually going to bring up an instance of the software here. For those of you who have never seen it before, this is Global Mapper. What is Global Mapper? It's a desktop GIS application. I've already loaded some data in here. I've got some imagery. Behind my imagery, if I turn off the imagery file, I've got some terrain data. This is just an initial visual reference for us. We're going to be planning our mission here, or simulating the planning of our mission. We give ourselves a geographic perspective. Global Mapper, how do we define it? What is it? What differentiates it from other applications? Well, it's a completely interoperable application, perhaps the most interoperable application in this field. It supports 300 plus data formats. I'm not sure what the exact number is anymore. We keep adding additional formats. We've been saying 320 something for a while. It's probably more than that. So whatever data you're working with, chances are Global Mapper can read it, and if it's applicable, can export it as well. So for a lot of people, that defines the application. It has a slew of digitizing tools or vector editing tools. It has image processing tools. It has terrain analysis tools. And relatively recently, we've added a lot of tools for point cloud processing. They are incorporated into a module that you can add on to Global Mapper, and it's called the LiDAR module. A little bit of a misnomer because it works with more than just LiDAR data. As you'll see today, what we generate from pixels to point is not technically LiDAR, as Mackenzie will illustrate a little bit later, but you can use those tools. So all the way along the bottom of my toolbar are tools that we can do things like do a comparison between point clouds, do a proximity search for points within a point cloud. We will be using some of these in our workflows, point cloud thinning, for instance. We can do a QC process on a point cloud to adjust its vertical accuracy. So this LiDAR module, as we call it, allows you to do a lot of really cool things with your point cloud. And again, we will see some of these a little bit later. So if you want more information on the core functionality of Global Mapper, I suggest when you get the link to this playlist, look at the very first webcast, GeoTalks Express webinar we did several weeks ago. That's an introduction to the software. For today, let's talk about it in the context of using a drone. If I have a copy of Global Mapper and I have a drone, what can I do? What can I do with it? Well, obviously, we're going to process the data in just a minute. But before we get there, it is worth noting some of the other functions that we can apply for initial flight preparation. we can do some basic reconnaissance. So let's say this target area is where we're going to be flying. I have a couple of data sets, as you can see. I've got some imagery, I've got some terrain data. These were both streamed from online sources. We have access to online data. I'm not going to open the dialog box, but we can connect to online data to bring in some imagery, to give us a visual perspective of where we're going to go before we actually go to the site. Some of these online services include weather. So if you want to see what the weather's like, if there's any clouds in the area, you can see that, or any rain coming. We can stream the weather data. We can also stream navigational charts, worldwide navigational charts. That's one of the other options as well. So you could see what regulatory issues you need to deal with in terms of the area that you're going to be flying. So a lot of pre-flight reconnaissance can be derived even before we go through the formal flight planning process. Measuring might be useful. We have a measure tool. I'm just quickly going to show you this. How much area do we have here? What sort of coverage am I going to get? I'm just quickly going to draw a polygon. As you can see, right at the bottom of my screen, without even finishing the measurement, you can see at the bottom of my screen we have length, enclosed area. My unit of measure, square kilometers. We're at 0.05 square kilometers here. You can change those units, obviously. Those are configurable. But it gives, again, an initial idea of how much area we're talking about here. One of the other things we can do, if I draw that polygon, I'm just quickly going to draw again. I'm doing this very roughly. But if this represented my project area, I'm just going to assign this to a temporary layer. Nothing, something I'm going to keep. But with this polygon, and with the presence of some terrain data, I can do a terrain report, if you like, by selecting that polygon. One of the options I have under attribute style functions is to apply the elevation stats, or look at the elevation statistics for this feature. In other words, enclosed within this area. And we'll go ahead and look for our maximum points as well. I'll say yes to that. And here is a report on the terrain characteristics. Again, this is useful information. What's my high point? What's my low point? What sort of slopes are we dealing with? This might help in determining the flight parameters that we're going to plug in before we send our drone up into the air. That information, all of this detailed information, is also accessed within this polygon now. If I select the info tool and select it, again, we have all of this attribute data now associated with our project area. A quick report of the terrain characteristics, as well as you see as a byproduct, we know the low point and the high point. So we've got a snapshot of what the natural environment or the terrain characteristics are going to be in that area. Other things we can do by way of preparing, we can bring in other data layers, obviously. Maybe we want to bring in property ownership. Are there any overflight restrictions? Who owns the properties? Whose property we're going to overfly? Bringing in property information into Global Mapper gives you that perspective as well. So just a quick illustration, like snapshot, if you like, of some of the tools that would be applicable within Global Mapper before you begin the actual process of initiating your project. Anything I'm missing, Mackenzie? Anything you want to add to that, or anything that you would think or hear from our customers about how they would use Global Mapper prior to sending a drone up?
I think it's worth mentioning the online data sources that are available through Global Mapper.
Yeah, we did a
and
little.
Just loading some freely available data. A bunch of sources, some aviation charts for different areas of the world, as well as just imagery and publicly available elevation data, help you get a sense of the area you're looking at.
Yeah, absolutely. I mean, I mentioned this before, the sectionals. I'm not going to click on it right now when there's some bandwidth, but if you want to set this up, this is a free service. You just go in and click the globe button in the toolbar. Under aviation charts, you can see the sectionals are here, and it will give you that, any regulatory issues you need to be aware of. And obviously, on a more practical level, you need to be aware of what issues are in place in the local area that you're going to be planning this mission anyway. So again, Global Mapper, before we start, a lot of really cool functionality. So let's assume we've sent our drone up, we've flown, we've come back. We've also gone out and we've collected some ground control points. Maybe we've done that as part of the initial planning process. I'm going to go through the process of loading that data into Global Mapper, show how we can do that. Now, from off screen, let me go ahead and bring my folder up here. And all I'm going to do, if I can move this out of the way, we'll bring it into screen so you can see what we're looking at here. I'm just going to select all of the images. These are my drone images. Just going to hold my shift button down and select, just to show we can just drag and drop, quite literally. Those drone images are now rendered in the application as what we refer to as picture points. These are based on the geotag of each image. the precise location where that image was taken from. And obviously this is critical. As we go through the actual process, we're going to see that this is important as to, in terms of how we process this data. Where was this this drone? Not only from an XY perspective, but also from a Z perspective. I can click on one of these images and it will show me. It's a little preview, and this is actually opening up an external application. Whatever image viewer you use, it will pop the individual image up in that image viewer. You'll note in my control center over here, I've got all these images listed. Just to tidy this up a little bit, I'm going to select them all. Just going to hold my shift button down, select all of these, and I'm going to group these together. I can right click and select a group, basically condenses them into one list. So images, or whatever you want to call this. This is just something internally within the application for organizing the data. And that's a little bit cleaner. So you can see images now as an expandable list rather than one long list. What else about, yeah, if I hold down the control button while I select one of the images, I also get all of the data. This is the EXIF data from the image. We can see the resolution, we can see the camera roll, the pitch, the yaw, etc., etc., etc. Not really necessary, but useful to see, for instance, the elevation, height above ground calculated here. Based on a local ground surface, how much height does this have? What was the height of this drone? So again, you can see all this information holding down the control button, again using the info tool to get that information.
We had a question come through asking if images like this can be loaded, taken with any GPS-enabled camera, as long as it has that geotag information.
Absolutely.
And that is true. Yep, they'll come in as picture points here. You know, if you take a photo on your smartphone with a GPS enabled, you can load that into Global Mapper, and it will appear as one of these picture points with the same functionality to open a preview of the image with the feature info tool.
I've heard a story, somebody, rather than sending their camera up on a drone, climbing a step ladder and taking photographs, top-down photographs of a particular object from multiple perspectives, and it works as long as you have overlap. And Mackenzie will tell us a little bit about the technical requirements, but as long as those images have overlap, you'll be able to proceed with the process we're going to introduce a little bit later. Let me also load my ground control points. So let me go back up one level here, and this is just a shapefile. And I have to say, in this example, again, drag and drop, this is simulated. These are ground control points that we added after the fact. Because of the data was not something we collected ourselves, we decided we would pretend, if you like, to show how ground control would work. It's something that you can do. It's not required. Mackenzie, I think, is going to tell us a little bit about this as well when we get into the application, the function of ground control. But in this case, I've simulated the process. This was, again, just a shapefile. I believe there are 9 individual points. The key here is that each of these represents a recognizable feature. Difficult to see in this low-resolution base map. We'll see it more clearly when we actually bring in the drone images themselves. But the important thing is each of these has an XY. We know where it is in the surface of the Earth. We also have an elevation. And this gives us the ability to more precisely position the output files, the models that we're generating through this process. So ground control, we'll see how that applies in just a second. So I've loaded the images. I've loaded my ground control. We are ready to initiate the process. But before we do, I'm going to hand over to Mackenzie, and I'm going to allow her, just one second, and I'm going to get Mackenzie, you should be able to control my machine now. And I'm going to give her control and allow her to walk through the process of what exactly we're going to be doing from a technical perspective.
Thank you, David. So the Pixels to Points tool is what we'll be using in Global Mapper, and that uses a process called structure from motion. And the structure from motion process is what constructs the 3D environment. And this is used by Pixels to Points and other programs that do similar processes. So there are a few requirements for your images for the structure for motion process to work well. Firstly, the target area that you're capturing images of needs to have texture and identifiable features. So this means that your images should be in focus. They shouldn't be too blurry. They need to have features that you can identify visually. So this doesn't work well with large areas of a single color, like areas of sky or snow cover. That can cause some issues with the reconstruction. Secondly, the images need to have some overlap between them. We say shoot for approximately 60% overlap, but as you're flight planning, it's always better to shoot for maybe 70% overlap so that you are sure you have sufficient overlap between your adjacent images. So the structure for motion process actually works by identifying like features based on recurring pixel patterns in the overlapping images. The identifiable features in your images have, unique pixel patterns that can be identified in multiple images, making that into one point. And then the program uses triangulation to recreate that 3D environment, find that feature in 3D space based on the slightly different angles and views of that feature from the different images. And those points become part of the generated 3D point cloud. Ground control points, as David mentioned, can be collected in the field when you are collecting your drone images, and these can be used to improve accuracy. We'll talk about these a little bit more when we look at the Pixels to Points tool, but you'll tag your ground control points in your drone collected images to help the program find those features and locate those in coordinate space. So the structure for motion process creates a point cloud, but does it create LiDAR data? It sort of creates LiDAR data. This is a yes and no answer. What the structure for motion process creates is a photogrammetrically derived point cloud that is similar to LiDAR, but there are some notable differences. Firstly, it is created from processing 2D captured images. It's not created from an active data collection with laser scanning. LiDAR is an active method for data collection. It stands for light detection and ranging, and a light pulse is sent out. The returns are collected, and that generates the 3D points for the true LiDAR data, whereas the photogrammetrically derived point cloud is generated by collecting these 2D images and then processing them together into a 3D output. So the structure for motion generated point cloud often doesn't do as well identifying ground points, especially in heavy vegetated areas, whether there's big tree cover. And this is because the process can only construct a point cloud for what is seen in the images. And while your drone's flying over a forest, you're capturing images of the tops of the trees. So that is what's going to be reconstructed with this structure for motion process. It won't have the data, the information, and the view of the ground to be able to create that ground layer beneath the trees. Overall, capturing images with a drone is less expensive than capturing true LiDAR data. Most drones have the ability to easily carry a light camera. A lot of them come with a camera. You can easily capture pretty high quality images, whereas to collect true LiDAR data with that active method, you may need a bigger drone to carry a bigger, heavier, more expensive LiDAR sensor. So the photogrammetrically generated point cloud is a 3D point cloud, and although it is not true LiDAR data, it can be treated as LiDAR data, processed like a LiDAR point cloud, and exported from Global Mapper to a LiDAR file format, such as an LAS or LAZ. That file can then be loaded into another program, and it will be treated as a LiDAR file.
So it's a fake LiDAR, is that what you're saying, Mackenzie? We're faking that. No, and this goes back to the introduction I went through very quickly, where we have the LiDAR module, and we want to make sure that while we call the component of Global Mapper LiDAR module, it is not specifically LiDAR that we're going to be working with, but you can generate LiDAR. You can export. If your deliverable is a LAS or LAS file, you can absolutely do that with what we're going to be showing you in just a second. Lots and lots of questions coming in, kind of overwhelming here. A lot of the questions you're asking, we will be answering in due course. You're anticipating some of the practical workflow we're going to be getting to in just a second. Questions, some people are asking for recommendations of for drones. Mackenzie, I'm not sure if that's a question you would get commonly when you're answering customer customer questions, but not really something we want to get into too much. That's really not our business. Certainly the only requirement for pixels to points is that your captured images are geotagged. Beyond that, really it's up to you how much money you want to spend on the hardware itself. Some folks are asking about the planning process, and to clarify, Global Mapper does not provide the flight plan itself. Global Mapper does some initial reconnaissance. When I've loaded up the data, we can scope out a project area. The actual flight planning that you would transfer to your UAV itself would be done with the dedicated application. What we're about to show is what we then can do with that data that comes out. That's our intent. So again, we will answer the rest of the questions that are coming in. If we can't during our session, we will certainly follow up with you and give you more specific answers. Some of these are going to require a little research as well. So let's go back to Global Mapper itself. And we have the images in, as you note. We have the ground control points in. A little bit of a low resolution backdrop here to give us perspective, just to see where we are. The tool itself is pixels to points, which is right here in the LiDAR module toolbar, where my cursor is located. This is a recent addition added a few years ago. It's a function that we've been doing a lot of work on recently. Every release of the software enhances this functionality. If you're using an older version of Global Mapper, the layout has changed a little bit. We're quickly going to go through the process of setting up the procedure for generating our data. I'm going to begin by loading the image files that I have on the map. Actually, before I do this, I'm going to have to cancel. And that's fine, we'll close because I need to display these on the map first. So we'll turn on our picture points once again, and once again we'll go into our pixels to points tool, because one of the options I have here is to load the loaded picture points, add the loaded picture points. I could go straight to adding the images themselves just by browsing. I didn't have to load them into the map. I think it's a good idea though, to get that initial perspective to see what coverage we have. So I'm going to add the loaded picture points, and we will see the tabular view of the loaded data, and we'll see a preview window. This is my first image, as I believe this is the crew here that's just launched the drone. And you can see we can go through each one and see in this preview window what it contains. If I scroll down a little further and get to one of the more interesting ones where the buildings are, you can see some of these recognizable features. We can zoom in a little closer here and get some more detail, and we'll show how that's applicable in just a second. Why would you want to zoom? What's the context of zooming? Also noting here, when we look at this tabular view, we have the relevant EXIF data or metadata for each photograph, including elevation or relative altitude, the image size, and we'll talk about the importance of that in just a little bit, and the specs on the camera noted here as well. Kenzie, do you want to talk all about adding ground control points to our project?
Absolutely. Absolutely. So we have the images loaded up top here, and our next box is for ground control points. So you can load these from the file menu as well, import ground control points from a loaded point layer, what we have, or load them from a text file. So we will import from a loaded layer, scroll through this list to find the appropriate ground control points shapefile. And you can see now that these points have been loaded into this ground control points dialog with the information, the coordinate location, elevation here, as well as the point name. So you can see that I have a ground control point selected, and some of these entries in the image file list have turned green. So I'll select ground control point 3, and you can't just load the ground control points into this pixels to points tool. You need to actually locate them on your drone collected images. So these green listed images that's Global Mapper suggesting what images in which this ground control point may appear. And that is done based on the coordinate location of the ground control point and the approximate image coverage for each of these images. So to actually add the ground control point to an image, you'd click here to add a control point to image, and then we can zoom in on the image, scrolling here, pan if needed, and place that ground control point. And move on to the next image. You can see now that I've placed the ground control point. The image list entry here is in blue, noting that the selected control point has already been placed in that image. And we would continue this, adding a control point to each image for all of our control points.
And just to clarify, what Mackenzie's tagging is not actually a ground control point. We did identified something in the images to simulate a ground control point. Obviously, before you collect the images, before you send your drone up, you would have identified placement of a target or something of that type. That would be the basis of your ground control. We're just pretending that this was a ground control point in this case. Question, Mackenzie, do you need to identify the ground control point in all of those images? How many images, in other words, do you need to tag a ground control point?
You should tag your ground control points in all the images in which they appear. This tagging of the ground control point will help to improve your accuracy, especially if you tag all of the images where the point appears, help to start identifying those like features and locating them in coordinate space as well.
And obviously, it takes a little time. It's a manual process to go through. If you misplace, somebody asked about misplacing a ground control, you can delete that ground control point from that preview window and replace it if necessary, or just remove it if you're not quite certain if that's the location. So you have the option to edit. Moving along, obviously, this is something, if you were doing it in the real world, you're going to take the time to tag and identify each of those ground control. We've had a few questions come in about the orientation of the camera, and these are obviously top down or nadir. If your images are more oblique, and it is certainly supported. People asking, can you take oblique images? Absolutely, you can. In fact, this building you see off to the side here in this preview, if our objective was to generate a 3D model that more effectively targets the building, you will want your images to be more oblique, and that is certainly supported. That'll work very well. In situations like that, when you're dealing with oblique imagery, it's quite likely you're going to get content off on the horizon that's not relevant, and that's going to slow down the process and create data that's not necessary. And I think of the situation where your oblique images are looking 45 degrees, you're going to probably get sky view in the distance, or at least you're going to get distant horizon objects. We now have a tool for addressing that. We can remove the pixels specifically, or the areas of our image that we don't want Global Mapper to process, and that's through adding a mask. I'll just go ahead and grab control here, and we have a new mask option. Obviously not relevant for this particular image, but just to show how the process works. A couple of ways we can add a mask. One is by drawing. Quite literally, we can draw the outline of what we want to remove from the processing, or we can choose a color. And there's a little flexibility slider here. Do you want it exact, or do you want a little bit of flexibility? This is good for sky view or water view or snow cover if you're looking at distant snowfields, things like that, which are going to really confuse the processing tool and will eliminate them from the analysis. I'll quickly use the draw option to show how this works. I'm not obviously doing this with any level of accuracy, but it's a digitizer tool. We're basically drawing something here. Left click, right click, like we do with the digitizer, and it's masking out this area. Obviously, again, if this was real, I may be looking at the horizon here. You can also select it and delete it as well, using the delete key on my keyboard. I am sure it's gone. So you have a little digitizing tool within the context of these images, and again, they have to be done individually, unfortunately, but color selection and that fuzziness slider will let you do that a little more quickly if it's a consistent, recognizable set of pixels that you want to remove. So that is masking. Mackenzie, you want to tell us a little bit about, somebody actually asked this question about coverage, deriving coverage for each of the images. I don't know if we've got enough screen real estate to play with here, but maybe drag the dialog box to the side so we can see the results of that.
Absolutely. So with our image here from the image list, right-clicking on a selected image entry, you have some options to load a ground coverage polygon for the selected images. We can click that, and you have options to load this coverage polygon for all of the images, but we're going to choose just to load for this one particular selected image. You can set the style because a vector feature will be created in the main view of Global Mapper here. And clicking OK, I'll move this dialog out of the way, and we can see that this coverage polygon has been generated for one of our images. This is the approximate area that image is looking down at. And Connected to that, we also have the option from this right-click menu to load the selected image as an ortho image. Now, this is not 100% an accurate ortho image, but it is projecting this image to fill that coverage polygon. Again, we'll choose just to load for the one selected image. And this option here is letting us know that we will get a more accurate ortho image if we run the pixels to points tool through first and actually process these images with that structure for motion process. We are going to continue anyway, and that should have loaded our single image projected onto our map here, filling that coverage polygon. So that's a good way to preview the images on your map if you would like, and it also helps us to see how much overlap we have. We can see from this one image, coverage area and the loaded image, that there's a lot of picture points within that coverage polygon, meaning that there is sufficient overlap between this image and the adjacent images. So this area should reconstruct fairly well.
Okay, and again, if you do the coverage polygons for all images, it'll look a little bit messy, to be honest, but they're all vector features now. They're all polygons, essentially, and you can select them, and you can basically run through a number of the digitizing and vector processing tools in Global Mapper to select them, recolor them if necessary. So yeah, we've got all sorts of options. We're getting a lot of questions coming in here, Mackenzie. Again, with apologies for those of you who are asking questions that we don't have time to answer, we will follow up. Mackenzie's probably sweating right now because she's going to be one of the people who's going to be answering these questions after the fact. I think you've got a couple of weeks' work here in front of you, Mackenzie. A question about the requirement for ground control. In this example, the ground control didn't exist originally. In fact, what we're going to show you did not actually use ground control. These are fake ground control points, as I mentioned before. Ground control is not necessary for the process. What ground control will do, and if there's any surveyors among you there, I apologize, but what ground control will do, it will more accurately tag what we're going to output into the real world. For the model itself, the model is going to be correct internally within the model or within the point cloud we generate. And if you're just looking in isolation at this one area, it's not critical that you have ground control. In fact, you can proceed without ground control. But again, ground control is going to give you that geographic accuracy. I also should mention, and I'll point this out when we finish the process, there's a couple of post processes you can go through as well to improve both the horizontal and vertical accuracy of the output file. So we're going to quickly run out of time here, so let's keep going. Output. Speaking of output, what are we actually going to generate here? And let me quickly point out in the interface the three primary files that will be generated. Well, obviously, we're going to generate a point cloud. That is the basis for everything that will follow. This is like LiDAR, if you like. I'm not going to do it, but we would select an output file location, and it's basically a GMP. It's a Global Mapper package file that would be generated. Even if we don't select, by the way, an output, it will generate the point cloud internally, and you'll have it rendered within the application. You can then save that from within Global Mapper. We also have the option of generating an ortho image. Now, ortho image is a top-down view. That's a gridded version of the point cloud. Unlike what Mackenzie did with the single tile, which was basically take an image and ortho rectify that, this is a version of the data that is a rasterized version of the point cloud. By definition, an ortho image is an image where every pixel is correct in horizontal geographic space. So that is the theoretical output that you're going to get from our ortho image, all distortion rectified and corrected. We will also generate a mesh, a 3D model. This is the eye candy output, and we'll take a look at this in our 3D view in just a second. We'll generate a 3D model of the target area. And there are a couple of other options in here to point out. We can create a cleaner point cloud by going through the entire process and then essentially resampling based on what we generate with the mesh to remove noise. You'll see less noisy result. It's going to take a little more time because it obviously generates a point cloud, then a mesh, and then a new point cloud. So but it does give you a cleaner point cloud. We can also generate an ortho image from the mesh. Again, takes longer. If that's your choice, you can do that. So a couple of options in here. You can also orthorectify each image individually. That would, again, perform what Mackenzie showed for every image, so you end up with, I think it's 148 individual ortho images. You'll see my, my image count up here. Final output is a log file. Basically gives you some technical information about the process that has happened. This you will see in real time on the screen, the status bar that you'll see when this process starts, gives you that information. This is collected and saved in a log file that you can choose to output as well, if you so choose. Mackenzie, you want to talk a little bit about some of the settings? Again, we maybe not too much detail there in the interest of time.
Yeah, absolutely. So the first option we have here is to reduce the image size by a specific factor, and this can help to have the process run a little bit faster, and it will use less memory on your machine if you reduce the images. This is really having to do with how many images you have, their original size, and the specifications of the machine on which you're running this pixels to points tool process. If you do go to run the process down here and you're choosing not to reduce the image size, Global Mapper will estimate if you will run out of memory, and if it appears that you will, the program will suggest an image reduction factor, just so you get that completed output. Next, we have the option to use a relative altitude based on a ground height. So here you would enter a ground height, and that would help to adjust the altitude of your images. This can be helpful because sometimes with certain drones, certain systems, the vertical is offset by a certain amount, or is not completely accurate. This is just another way to help boost that accuracy by specifying your ground height to begin with. And our third checkbox option is to harmonize color. So this is useful if you have images with great color differences across the set. Sometimes that can happen if you're taking images with the camera in an automatic mode, or the shutter speed is different for all of your images, or if you start your flight later in the day and the first half of your image set is in bright sun and then the sun dips behind some trees and you've got some heavy shade towards the end of your flight. With this harmonized color box checked, you can right click on an image in the image list and choose to set that as the reference image, that baseline for the color harmonization option. Below that, we have the analysis method. The Pixels to Points tool offers two analysis methods, either incremental or global. So this has to do with that structure for motion process and how the images are taken in to perform that process. The global method works by looking at all the images at once. It brings in all the images, starts identifying those recurring pixel patterns to find those like features, and locates them in 3D space across the whole image set at once. The incremental method, on the other hand, starts with two images, identifies the recurring pixel patterns, those identifiable features, and then locates them in space, brings in another image, adjusts the existing points, finds new ones, and then brings in another image. So it incrementally adds one image after another until the entire image set has been added and points located. Below that, we have a couple drop-down options, one for quality. The default is normal, and that is a high enough quality for most applications. This can boost the density of your point cloud and maybe the appearance of your mesh a little bit, but increasing the quality will take longer to process. This setting is more applicable when you're using the incremental analysis method. And lastly, we have the camera type. This helps to account for distortion towards the edge of your images. Any image taken with a single camera lens will have some distortion around the edges, but there's a big difference between the distortion with a standard pinhole camera versus a fisheye or spherical camera, where there is much more distortion. So just setting that camera type up appropriately will help to account for that distortion in your images.
Got a few more questions very quickly here. And again, a lot of you are asking questions about specific hardware, and we're going to defer those to kind of follow up. We'll do some research ourselves on those specific hardwares. Someone was asking about the coordinates, specifically where the coordinates derived from. Is it the center of the image? And to clarify, the only coordinates we have to begin are the coordinates of the drone when the image was taken. That's what's used, and it's a simple triangulation process. If you remember back to Mackenzie's slideshow, that derives where the surface is, well, ultimately where each point is, from the knowledge of the coordinates of the camera. From that, then obviously we know what the coordinates of each point is and the geographic reference information. Someone asked if the base image is required. No, it's not. We could have done this with a blank screen on Global Mapper. I like to throw it up there just for visual reference, and it's a good idea. You have access to a lot of free data anyway. Might as well use it. So again, those questions are literally coming in as we speak. We'll follow up. Please check out the blog article, which will be posted hopefully within the next few days, that we will answer all of your questions, and everyone can see your questions and see the answers that we come up with as well. The question came up a while ago. I didn't address this one, but how long it takes. Mackenzie, this is a good segue. If you were to initiate that now, give us a ballpark as to how long this process would take for this data.
For this data, it does depend on the settings that you're using in the Pixels to Points tool, whether you're reducing your images and then the computer on which you're running this process. I believe running through this image set, it would take about an hour and a half, maybe.
Yeah.
On my computer, at least. I don't know about yours, David.
I think it is. This is actually my laptop, and I actually did this. We're going to see the output. It was about an hour and 20 minutes, I believe. I'm not sure because I walked away and did something else and got back and it was done. But about an hour and 20 minutes to do this. You can obviously improve that by, as Mackenzie mentioned, reducing the image size if necessary. You're obviously going to reduce the quality of the output by doing that. So we'll pretend at this stage, and we'll go about 15 minutes left, we'll pretend we hit the run button. We're not going to, obviously. I'm going to show you in just a second what we were able to generate. While we're doing that, I'm going to set up I'm going to introduce a poll here. We're going to ask you to give us your feedback. You're going to see a question appear on your screen about whether you currently use a drone or UAV for mapping project. Is it something you currently do? And there's a few different options that you can respond. You can say, yes, you use a drone and you use Global Mapper and the LiDAR module. Or yes, you use a drone and you use another application. I use a drone, but I don't use it for mapping. Might be an appropriate response. You can choose the one that's most applicable. Maybe you do not use a drone, but you plan to start using one. And the bottom one, I hope there's nobody will choose the bottom one. I have no interest in using a drone. I would have to ask, why are you here? But that's fine. If you're just here to find out more about Global Mapper, that's perfectly understandable, but no intention of using a drone. So while that's chugging along, we'll give you a few seconds to respond to that. I am going to switch and we'll pretend that we have completed the project. And when we come back, you'll magically see the output from our process. So just a few more seconds on the survey, and we'll go ahead and close it. Now, again, I like to share the results with you so you can see who you're sharing the data with. Quite a few of you are using another application. Quite a few of you are not using drones, but you plan to use one. I know costs of the hardware are coming down significantly, so it is accessible, more and more accessible. And now that you know from a mapping perspective what you can derive, a lot of people are interested. And there's 2% of you out there who decided to stop in today, but have no interest in actually what we're talking about, which is fine. Let's close the poll, the results, and you should be seeing on my screen now what we generated. I'm quickly going to go through an overview of the files that were output. There's actually 3 files, as we noted. There's the point cloud, there's our ortho image, and here's our mesh. I'm going to isolate each one, and we'll talk about them individually. Here's the point cloud itself. There are 15, you may see it peeking out the side here, but 15.7 million points in this point cloud covering this area. You'll notice a little bit of a gap here, and the simple reason for that is so we remember where our images were taken from. We're looking at kind of the shadow or the downward side of this tree, so we didn't really get enough data to fill that in. It will be interpolated in the ortho image and on the mesh. The gridding process does that, but in terms of the point cloud, we don't have any coverage. Similarly, over here in this vegetated area, we didn't go quite far enough to capture a lot of data over here. The primary target area we did, as you can see. I like to go to the metadata for a point cloud, regardless of its source, because this gives me a snapshot of what we have. And you'll note here, we have 361 average points per square meter, an average spacing of just over 5 centimeters. So this is a very high density point cloud that we were generating. In fact, it's a little too dense for what we need it for. We're going to generate a DTM in a minute, so we're actually going to go through a thinning process to remove points that we don't need. But it's a good start, snapshot again of what we have from output. The other thing we note here is statistics. All of our points are unclassified. If you're using standard LiDAR, you'll have classifications pre-assigned, unclassified or ground or buildings. We are actually going to apply classification to this output point cloud in just a second, and I will try to remember to revisit this dialog box to see how many ground points we're actually going to derive from that. So that's output number one. We'll come back and visit it as I mentioned. Output number two is our ortho image. It looks exactly similar. It's a solid image. This is a raster layer. This is a top-down, two-dimensional, if you like, view derived from the point cloud. A gridded version of the point cloud. Obviously, the colors are derived from the images, and you can see the quality getting down pretty close here. Certainly a lot better quality than the original image we were using for visual reference. You can see the lines in the road. You can see our simulated ground control point here. Again, so you can see what it is in the actual image itself. So that is our ortho image, and the final output is going to look similar again. It is our mesh. In the 2D view, top-down view, it looks similar. If I zoom in a little closer here, you will see we'll actually see the components of the mesh. The mesh is actually a vector file, and you're seeing the interlocking triangles here that derive the mesh, that derive the model. This is what it looks like structurally. When we zoom out, we lose those outlines of our triangles, and we'll actually see it as a solid surface again from the top-down perspective. But where this really comes into its own is if I pop it up in 3D. And in my 3D view, you can see what we were able to generate. Now, when I did this, I was actually very surprised that we got the detail that we did on the side of the buildings here, because again, these were top-down images. We weren't looking at oblique images, but it did a very good job reconstructing our buildings here, even our windows, etc. There's a little bit of interpolation in terms of the trees. As we noted, there wasn't a lot of point clouds, so the trees are a little irregular. But certainly the building looks good. And really for what we want, we're looking primarily at our terrain surface here. We're going to do a little bit of contouring from one of the derived output products. So for obviously the open terrain, a very accurate surface model has been generated. So that is our mesh, that is our generated point cloud, and that is our ortho image. Kenzie, I want to talk a little bit about maybe doing some point thinning here, because again, we have way more points than we need. So maybe introducing our thinning tool.
Absolutely. So this point cloud has 15 million points, and as David showed in the metadata, it is a quite dense point cloud. In Global Mapper with the LiDAR module, we have this option to spatially thin LiDAR. And what this tool can do, it will thin out the LiDAR and create a point cloud that has fewer points. We have this 3D thinning option, which will intelligently thin the point cloud to keep more points in the steeper areas to retain some accuracy there. And up at the top, we will choose an output resolution of 5 times, or reduce the point spacing by 5 times to create a thinner point cloud. And we will create a new layer with these thin points. Clicking OK. This just takes a few seconds, and we have our thin point cloud up here with now only 3 million points, which is still plenty of points. Turning off our original point cloud, hiding that, you can see that this point cloud does look thinner. There are fewer points. It's not quite as dense, but it is still dense enough for our further analysis that we will be doing. Should we move on to ground classification, David? Do you want to talk a bit about that?
Just going back to some of the questions, I will in a second, Mackenzie. Just one of the other questions that came in earlier about ground control, and if you want to apply some sort of rectification as a post-process, there's a couple of ways of doing that. I mentioned the LiDAR QC. This will allow us to go out after the fact, identify recognizable features in this area, derive the three-dimensional coordinates of those recognizable features, and then import those points. And within the context, the local context of those points, it will adjust the vertical position of those points. It's a vertical offset, and interpolate between those points. So that's a post-process you can apply to improve your vertical accuracy. I also should mention, I'm not going to go there, but we have the option as well with the point cloud to rectify The rectification dialog box is primarily for image rectification. We use that in for bringing in non-geographic raster data and applying geographic intelligence. But you can use that with any data. And again, that will allow you to reposition based on your knowledge of what the coordinates of a specific recognizable point are. But in that case, it's both horizontal and vertical. So you can re-rectify as a post-process. So just addressing some of the questions that came in earlier with the need for ground control and as a post-process. So yeah, Mackenzie mentioned, we have this data now. Very quickly, I'm going to go back into the metadata just to prove what we saw before. Our density now is significantly lower, still quite high. We still have almost 60 points per square meter. We still don't have any additional intelligence in terms of what these points represent. One of the options we have in the LiDAR module is to change how our point cloud is displayed, for instance, by elevation or by classification. And classification in this context is obviously going to be a single color because these are unclassified points. Next workflow that we're going to go through here, and we don't have a whole lot of time left, unfortunately, but we're going to go through a process of identifying within this point cloud which of the points are likely to be ground. We have an automatic ground detection tool, automatic ground reclassification tool. Without taking too much time to go through the details here, I'll just leave the default settings as they are with a little bit of threshold, above and below what it recognizes as a local ground surface, applying it specifically to the thinned version that Mackenzie created. We'll click OK. And we should, as a result, in a few seconds, see an additional color applied to our map view. Now we have ground points. You'll see where it's eliminated the buildings, it's eliminated the vegetation. We had a question earlier about this. How do we remove trees? This is how you would do that. Those points that are unclassified are no longer recognized as ground. If my intention is to create a DTM, I have the material, the raw material now to do that. And to look at this from a slightly different perspective, I'm going to use my profile tool, and just where we have some of these unclassified points, I'll just draw a quick profile line. It looks like we're ignoring some of these above surface points. Maybe in some of the tree area might be a little more effective. Again, you can look at these trees, these parts of our tree which are going to be ignored, retaining our ground surface for what we're about to do, which is essentially transform this into a raster surface, which is the basis then for a lot of analysis that we can do with this. And we will, I think, ultimately end up with some contour lines if time allows us to do that. So Mackenzie, maybe you could take over and show us how we transform this into a DEM or a DTM to be specific.
All right, so we use the elevation grid creation tool in Global Mapper to do this, and we'll select to use our thinned point cloud. That is the one that David has just classified ground. So we're going to grid the elevation values to create a elevation model surface. We are going to use the binning minimum value DTM because this is the method that will help us to create a layer that models the ground and not the features on top of the ground. To help with that, we are going to click here to filter our LiDAR points as well. So this is an advanced filtering dialog. There's a bunch of options here, but for this point cloud, we are going to choose to only take into account the ground points, those ground classified points, when creating our elevation layer. And then we also have the option to specify a grid spacing. We're going to use a grid spacing of 1 meter. You can choose to have the program determine the grid spacing based on a multiple of the point spacing, but you can also specify this in meters if you're looking for a specific resolution output. Clicking OK, we see that layer generate pretty quickly. And turning off the point cloud, we can now see this elevation layer showing the ground. There's not huge spikes over here where there were trees. There was a tree around this area, and we're seeing that relatively uniform in color with this shader. And the building as well over here is not showing on this generated elevation layer.
Yeah, and in my to-do list, I was going to be talking about contouring. I'm actually going to defer that now. If you're interested in what we can do with this data, this DTM, I'm going to suggest you stop back for our terrain analysis session in a few weeks, and we'll talk about things like contouring and profiling and volume calculation, all the things that we can do with this data. Ultimately, with our pixels to point workflow, we've achieved what we needed to achieve, which is processing the images, identifying the three-dimensional characteristics of our area, and then generating our DEM and our DTM specifically. Somebody asked a question about trees. Can you determine tree height? Again, going back to the slides that Mackenzie showed us with photogrammetrically generated point cloud, we don't have a lot of ground points underneath vegetation, so there's no way to do that calculation. If you're interested in tree height analysis, you'll be wanting to look at LiDAR, where you have ground and you have canopy, but absolutely, you can do a DTM minus DSM. You can actually generate a model of the difference between your canopy and the ground if you have that data, but with this data, that would not be possible. So, Mackenzie, I think I have time for one more quick show and tell here before we have to wrap up. One of the other things that I was able to generate from the original drone images, what is called a flight path. Basically, it is a linear connect the dots, if you like, where our drone was. In fact, if you load your drone images into the dialog box itself without loading them on the map, you can generate this automatically. These are the flight parameters for our drone. Now, to show what we can do with this, I'm going to turn the mesh on. Again, you can see the overflight. This is the flight pattern. It recognizes the orientation of the drone. It recognizes all of the other characteristics that we looked at when we clicked the info tool, the orientation, the pitch, etc. And we can actually play that back using our fly-through tool. Fly-through, by the way, is something you can do manually as well. Just draw a line and manually assign flight parameters. But because this is derived from a known flight path, this is automatic. To wrap up, if I pop up the 3D view now, this is our 3D view of our area, as I mentioned before. I can simply play back that line. Basically, I'm going to click OK, and you will see, I'm not sure how cleanly it's coming through in the broadcast version, but we're looking at the overflight, looking underneath at the mesh. And again, the trees don't look great here because of the nature of the data, but you can see we're simulating the flight of our drone over this terrain. Obviously, top-down images looking straight down, a little bit of a dead area over here on the right again where we have no data. I think we're about to turn, head back, and the speed is accurate in terms of ground speed, obviously the orientation, the pitch of the camera, etc., etc., etc. So this is derived specifically from that information that we saw in each of those individual drone images. This is the ooh and the ah part. So I think if we could hear your reaction, we'd hear lots of oohs and ahs. So it is remarkable to think that we started our program today with just simple drone images that had coordinates. That was the defining characteristic. And within a few minutes, we were able to generate a DTM that we can use for things like contouring and the visual elements that, for instance, that you're seeing on the screen right now. It's really, really cool tool. And I think this is the flight crew here where they park their cars. Again, questions. This is over. I see oohs and ahs coming in. Thank you for the oohs and ahs coming in the questions panel. That's really good to get that reaction. Overwhelming number of questions. I would not have anticipated this level of interest. Apologies for those who asked questions that we didn't have time to cover. Obviously, we had a lot to cover during the presentation itself. We will follow up. We've got a lot of work in our hands here, I think, to answer these questions. Somebody asked very quickly, how do they generate the flight line? It happens automatically. Again, load your drone images into the Pixels to Points tool. I believe it's an option in one of the menus at the top. Mackenzie, I don't know if you can remember. It's
from the map menu. You can load images that are in the Pixels to Points tool dialog back into the main view of the global mapper workspace, and that will create the flight line. And
it does automatically. And beyond that, I just clicked play and it went. You can obviously, again, do the flight line manually as well. So we overshot our time by a few minutes here. It's just after the top of the hour. But thank you so much for joining us today. Thank you for your interest. This is really, really overwhelming in terms of the interest we're seeing. If you want to try this yourself, you can. Website you see on the screen, bluemarblegeo.com/trial will give you a free trial of our software. If you have any questions specifically about the software, you can talk to our folks in our sales department if you have licensing questions, or GeoHelp, or if you're watching the recording of this and you have questions about some of the content, again, GeoHelp at bluemarblegeo.com, and the folks are standing by to answer any questions you have. All that's left for me to do is thank Mackenzie for lending her expertise this morning. Thank you very much for your help, Mackenzie.
Oh, you're absolutely welcome. Thank you for having me, David.
And for the rest of you, we will see you next time in 2 weeks when we go through the ABCs of Global Mapper.